Deze tijd. Ik moet je even persoonlijk aanbesteden. Stop eens wel. Dames en heren, ik stel voor dat we snel verder gaan. Yvonne, ik kijk jou even aan, want we hebben nou een trits TNO Marin Deltares. En volgens mij weet jij precies hoe die planning ook beter dan ik.
The first thing I know is that we're going to switch to English because some of the presenters want to do it in English. So, and they are brilliant in what they are doing, so they needed to be here. So we're going to do it in English. So that's the first switch we're going to make. And then in the preparation for this day, we thought of a nice build-up. And I think a couple of weeks before, I knew Sharon from Deltares from a long time. Yeah, that's years ago. So, but we visited TNO, and they explained us what they are doing from at North Maritime Spatial Planning on the Noordzee and stuff like that. So, and then it was like a kind of conclusion that we all like the Noordzee, we like the puzzle, and we like data. We only just work in different institutes, but we are doing a little bit the same thing, but a little bit differently. But so we thought, well, maybe we can join our forces and from the different perspectives. So from TNO, Deltares, and Marin, we will tell you something on what we are doing on the North Sea related to the puzzle and the things that we are. But TNO will start, and then yeah, and we have like 45 minutes more or less. So I'm not sure how. I think.
I'm always too flexible, but let's say 40 minutes. 45. Okay,
we'll see. We'll see. We'll close the door, maybe. It's a little bit warm, I know, but we already opened the windows.
Hi, everybody. My name is Aravind. I'm from TNO. I've been working in for about 5 years, and during that time, I worked a lot with maritime spatial planning. I work a little bit with urban spatial planning as well, but then today we won't be covering that. So I want to talk a little bit about the kind of maritime spatial planning we do, that I and my colleagues do at TNO. I wanted to begin by saying why we do that. Noordzee is busy and everything. But from the previous presentations, you saw a lot of maps, and you already saw that it's pretty crowded. So I'll move on to the next part. Because it's very crowded, you need, obviously, you need a little bit of planning. And we call it MSP, stands for Maritime Spatial Planning. MSP has, for an effective maritime spatial planning, you need spatial data. You need socioeconomic and environmental data, legal and institutional framework, engage with a lot of stakeholders, scientific tools, and theoretical and conceptual frameworks. But at TNO, I work in a program called the Noordzee Energy Program. Later in the day, I can explain what the program is, but we mostly work on these aspects. We don't work with the socioeconomic part and the legal part. And today I wanted to talk a little bit about the spatial data and the scientific tools, scientific and technical tools part, because that's where I am heavily invested. First part, the scientific and technical tools. And what I believe, or what I think is pretty cool that what we're doing over there is the spatial optimization part. So why do we need spatial optimization tools? So we saw a lot of maps in the previous presentations, and it seems like everything's already sectioned off, and you have, they say, okay, wind farms over there, shipping lanes over there, environmentally protected areas over there. So why do we need to optimize everything? It's because, I'll explain it through an example. I want to take that little yellow wedge, the big yellow wedge at the top. It's a area that is designated for building wind farms in the future. Now, the problem is that little area, in that little area, there are a lot of other people interested other than just wind farms. So you have areas potential for carbon capture and storage over there. You have an area that's suitable for carbon capture and storage, as well as oil and gas exploration. An area for CCS and hydrogen storage. A big bird migration route in the middle. And then many other oil and gas exploration options as well. And if you end up making space for everything, the yellow part is what will remain for wind farms, which means we won't have a lot of space left for wind turbines. So we can get creative by manually building a lot of scenarios. So if you're building oil and gas platforms, which are represented by the circles, a platform requires a safety area around it where nothing else is supposed to be built. You can play around with the safety zones, or you can play around with nature area. We're going to focus on this one, avoid that area, and maybe we decide, okay, we're going to prioritize wind over oil and gas. You can start making different scenarios, but the thing is, when you have too many objectives, there are limitations for the human brain. You need to take into consideration objectives like costs, cable routes, like when the entire area is sprawling with cables, shipping becomes a difficulty, and bird fatality, and then the objectives start piling up, and then it becomes difficult. So why don't we let computers handle the multi-objective spatial optimization? So I'm going to explain that part with an example. So this study was just a test of the concept. So let's not take any solutions that comes after this as like, this is what we're supposed to do. This is just to showcase the concept. So again, I'm going to take that yellow wedge as the example area, and a little area in the southwest part of it to show this example. The map behind it with so if you look at if you look at this map, it shows you something called a wind farm sensitivity index. If the value is high, it means that it's more sensitive to more harmful to birds. So the yellow areas are more sensitive to birds. And we want to build wind farms over there. So on the one hand, we want to increase productivity from the wind farms, so more wind turbines. On the other hand, we want to reduce bird fatalities. It's sort of opposite to each other, you could say, because the more wind turbines you build, the more harmful it is, or chances that birds get hit, and vice versa. So we ran we built a script, an optimization tool was connected to the whole thing, which you can look there if you want. And we get a bunch of solutions. So every dot that you see over here in the middle is a solution that the tool looked at. A solution as in a layout, a spatial layout. And then the dots that you see on the graph over here are the locations of the wind turbines that it plotted. So it looked at far more solution spaces than what I could have done on my own, manually changing variables. And the ones that I want to look at in depth would be the ones at the periphery. Mathematically speaking, these would be the best choices. And then I can pick up, with the help of a room full of experts, I can then ask, okay, which of these do you think is better? So that's how the optimization tool works. It looks at far more solution spaces than I can do on my own. And from there, with expert opinions, advice, I can choose a better solution. And where are we heading towards that? So when you have a wind area that is designated in the North Sea, very often these days there's a like I showed in the beginning, there is a gas field or oil and gas exploration area, carbon capture and storage area over there. And that's becoming a very common issue. And so we want to build a tool that would do something like, okay, before we section it off and give it and tender it off to wind developers to build wind farms on it, we'd like to see, okay, where do we put the carbon capture and storage or CO2 injection platform? If we do it at maybe if we put it at the very end of the gas field, we get a bigger area. Or maybe we put it in the middle and section it off into two halves and do it at different times. Maybe we put it a little north and then section it off. Take the smaller wind search area, build that first, and later on build the bigger, more fuller wind farm. And then we play the different objectives, cost, cable length, environmental impact, etc. And then what I'm hoping for, this is just an example, this is not built yet. What I'm hoping for is, so for each axis that you see, vertical axis, it's the scoring on an objective. And every horizontal-ish colored line is a solution space. So one of the, I would say an optimized solution space. So solutions at the periphery. And in a room full of experts, I present all my solutions to them. And then together, I can ask them, okay, what is the tolerance on each axis? With a bird expert, I ask them, what is the tolerance for that? With cable costs, what is the tolerance to that? And together, you narrow down on a few solutions. And then hopefully that will speed up the process of making solutions and get better solutions as well. So that's where I hope the tool is headed. And of course, all of that would not be possible without spatial data. And for that, within the Noordzee Energy program, we have collected a lot of open spatial data, open data, public data. About 99% of the data that we have over there is open. And we've categorized it into energy, transport, ecology, defense, fishery, etc. And kind of looks like this.
Yeah, wrong.
Oh, this one?
Yeah.
Yeah. So yeah, it looks like this. So these are, in Noordzee today, you find spatial data on what's existing over there in the North Sea right now. Then you have, I work in the geology department at TNO, so we get access to a lot of geology related data, so oil and gas fields. Then we also publish results on our own studies from the Noordzee Energy program, sort of ideas that we have made for 2035, 40, 50, etc. Yeah. And if you would like to explore that, you can use this QR code. Yeah, so that's about it. So we collect all of our data over there and make it public. Although we do have data on fisheries, nature, defense, etc., our primary focus is energy and energy storage infrastructure in the North Sea. The nature-related data and shipping-related data will be is better handled by Marin and Deltares.
A good bridge, actually.
Yes.
We thought about this.
Yeah.
Should we do questions for now or later?
What do you prefer, questions now or presentations?
Yeah.
Now? Questions?
How sensitive is the optimization algorithm to change in data? If there's new set of data coming in and you need to
Yeah, we would need to put, input the data.
Yeah.
It's still being built, so it's very early in its development, so it can be made more specific. Progress. Yes.
Yeah. So my question, actually 1.5 question. So can you also display something about the elasticity of the outcome, like how big the effect of a small change in the input data would be on the outcome?
Yeah.
Yeah.
Like I said, since the tool is still in development, if we think that the stakeholders would prefer to see that sensitivity, then it can be built into it.
Yeah. And the other question is about I've been in some of the MSP challenge tool sessions, and also where there were some people representing fisheries.
Yeah.
And so if they have a low trust attitude, and this tool is so complex, how do you deal with it? Because if they say, well, I don't trust that you put in that it's a fair tool, then all the work is for nothing. Do you have a way to deal with that?
I guess one way would be to get the data from them, and then to use the tool in a room where fisheries is represented by them. So fisheries, shipping, ecology, etc. And then we get the data from them, hold a longer workshop maybe, and basically run the tool with them.
Like this is competitive, something like that, done with fisheries involved.
Yeah, that's the idea. So because otherwise they don't know what the other person's doing.
Yeah.
I saw a question over there and then one over there, and then I think it will be good to continue. Okay.
Yeah, my question is about the OR component. Which kind is the MIP or? Sorry, I didn't put it here. Is the OR component is it like a MIP, or is it like more a MILP, or you don't know?
What is the OR?
Operations resource.
Like the model itself.
The model itself.
Oh, so I'm sorry, I can't answer that question because I'm not a software expert. I'm more of the content.
Do you maybe know the solver there you are using?
It's called Everest.
Everest. Thank you.
Yeah, thank you. Interesting presentation. I was wondering, is there also a cost element involved in this model? Because I've seen similar kind of scenario planning models made by software companies active in offshore wind world. They have a commercial product.
Yeah.
They're selling it to offshore wind developers. Are offshore wind developers the end user of this software? Yeah.
No, I believe offshore wind developers have their own very detailed tools to see where the turbines is supposed to be plotted. But there's more like a few steps behind before that. Right when the big wind farm search area is sectioned off and said, okay, this is the area that you have to play with at that moment.
Okay. That's more the RVO work, the Wind op Zee program. I mean, they also kind of give out the parcels, right?
Yeah.
So this is where you're going to plan your wind turbines.
It's kind of phrase like work it then.
Yes, there is.
I would like the phrase that that's worked.
Yeah, it'd be interesting to get in touch.
I think quite an answer, isn't it?
I think.
Last question.
Yeah, my name is Eric. If you talk about public data, spatial data, what kind of sources are you using?
Do you know NLog?
Yeah.
So TNO publishes a lot of data on platform locations, oil and gas platform locations.
Yeah.
So there's that part. We use a lot of that for the oil and gas information. Then for pipes and cables, Oscar, it's a wide range of.
Yeah, okay, so it's not that space data, but spatial data that you have from others.
Yeah, it's not satellite data.
Good, because you could use satellite as well for that. Interesting.
Yes. Okay. Thank you very much.
Good morning, good afternoon. My name is, no, not quite good evening, not yet. So we're going to carry on the talk about how to plan the North Sea. My name is Sharon Tatman, and this is my colleague, Luis. We're going to take you through what's happening just to make it a little bit more complicated, because as if it's not complex enough, we're now going to take you to the internet and basically try and plan the North Sea, but then in the international context. And we're doing that in the Greater North Sea Basin Initiative. So we are supporting the Ministry of Infrastructure and Water in this GNSBI. So I'll start from the beginning, explaining first of all what GNSBI is, and then I'll explain what research is that we're doing, and also how it matches what TNO and Marin are doing. So as you've heard several times this morning, there is a huge competition for space in the North Sea, for the whole of the wider North Sea, but also, very importantly, there is the ecological space is also under pressure. And this is fairly invisible, but just to give you a little bit of background, you don't only have climate change, which is changing the North Sea system quite fast at the moment. Temperature is rising, acidification, species are changing. It is reaching its boundaries already without all of these activities happening, wind farm developments and all of the other infrastructure developments. And already in 2023, the OSPAR Quality Status Report came out and already said that at that time, most of the indicators of the health of the North Sea are already sort of in the red zone. So, and now we're going to impact the sea more. And why is this important? It's not only that ecology, biodiversity is a basis for everything for us that, you know, we want to get and do with the North Sea. It's also, we have to comply as a nation with European directives. And I've mentioned a few there. So it is actually within our legal we have to comply with these European legislations and laws. So very quickly, what is actually marine spatial planning? It is a coordinated and integrated transboundary planning process. So it's not only about sectioning off parts of the North Sea for certain uses, it's actually doing this together with our neighbouring nations, doing it across sectors as well. And if you take the European directive on MSP as their definition, it has to be done within an ecosystem-based approach, which means that you always keep the ecosystem in mind and build up your evidence base. And if you do not know enough about the system and how things will impact, you have to take what's called a precautionary approach, which means that you have to stay, err on the edge of caution. So this means that we have to be very careful and have evidence based on what it is that we're planning on doing. And then the Greater North Sea Basin Initiative arose, started in 2023. It's an initiative that was started by the government of the Netherlands together with Belgium and France. It has now grown into a multilateral collaboration between all of the North Sea countries, and includes Norway and the United Kingdom. And this is really important because it's all done on a voluntary basis, and all countries have joined and are also staying together and working together on how to plan the North Sea. And more than half of the North Sea is actually part of Norway and the United Kingdom. So it's really important that we have this initiative. what is it? It's actually to strengthen the cooperation between all of the countries around the North Sea, and especially along the cross-boundary areas. That's where it starts getting interesting. When one country plans something, it always will impact another country. Yes?
Well, so there's the North Sea Energy Corporation.
Yeah.
Is that also related to this? Is it separate or is it?
It is related. It's there's a lot of overlap. I'll show you in the next picture. It's all of the same countries in GNSBI, but GNSBI has Sweden, and Sweden's not in NSEC.
Okay.
And I think Scotland has stepped out of NSEC, and they are in GNSBI. So yeah, GNSBI goes beyond just energy. It's basically all sectors, including fisheries as well, but less so shipping, but we'll get to that in a minute. The main thing about GNSBI is, why do we have it? It provides an informal platform for dialogue between countries. And there's my picture. So the red line is the boundary of the GNSBI area. And you can also see the NSEC boundary in yellow, practically the same. And so it covers 9 countries. I already said it's non-binding and it's voluntary. And it's really important to realize that, as we saw in the previous, so Aravind's presentation, countries decide on the use of their space within their own sovereign waters. So that's a national decision-making process. And we have tools, and all of the countries have their own tools to decide what to do what activity. But at some point, these activities will impact each other, especially in the cross-border areas. And that's why we have GNSBI. But the underlying agreement is that the national process is leading. And how does it work? Well, we have this thing called early MSP dialogue. So in the middle, you can see, I missed one thing. There's the Antwerp Declaration, which was signed 2 years ago by all of the ministers around the North Sea. And we have this annual event with ministers and DGs where we get together, present results, talk about what's happening. They can have their dialogues with each other, and then go back to their own national decision-making process. So it's a sort of a bit of a national development, have meetups. So next Friday we have an online DG meeting again, explain, and the dialogues are happening throughout the year. And we as a Knowledge Institute are involved. So you see, we're sort of trying to bridge that gap between what we think is the evidence base, tools that we're developing, informing decision-making process, and also having this dialogue with these the really high level political decision making. And when you have, so we have this thing called the early MSP dialogue. You have, so every country does their spatial planning in a different way, but they follow the similar steps. And they start with aims and objectives of what they want to do in their sea space, information gathering. That's where we are working together with Marin and TNO. We come up with plans. These plans are also then shown to stakeholders and engaged with them, and draft plans happen. And at that point, countries will then need to go and start having this dialogue with each other and informing each other. So that's how the process works within a nation and between the nations. And what are we doing as Deltares? We're working on a working track. We're responsible for the knowledge sharing, which actually also includes data sharing. And I'm doing that together with Nick Foxton from the Ministry of INW. And why is there a knowledge sharing track? Because, as it was already said this morning, I think you mentioned it, it's all about trust. It's all about sharing your data and your maps and your knowledge. And it's not an automatic process that happens between countries. And we as Deltares are trying to facilitate that process. Because otherwise you end up with things like this. This is actually the current marine spatial plans that are uploaded into the European portal, EMODNet, where we get a lot of our data from. These are actually plans that are still slightly, so these are previous plans, but these are the plans that the countries get to see of each other. Each country is updating their plans, but they don't get shared European-wide. And you can see that the Dutch shipping lanes are going straight into a German wind farm. All of that has been resolved, but that's being resolved through the dialogues that are happening. But if a country, and things are happening faster, so countries want to have updated maps, and at the moment, at European level, this is all they can find. And the problem is that countries have different ways of making their national decision-making. It's really difficult to get hold of these maps, especially at Noordzee level. So what we are doing is that we are trying to collect and produce maps at Noordzee spatial scale. We're developing engagement tools, which Luis will show one of them. And we are also thinking about the future. We're starting to implement the tools that we have into the European Digital Twin of the Ocean, because that's the program at European level that the Commission is now funding. A lot of their resources and strategy is going into that. So we've decided we should jump on that bandwagon as well. We have the tool, which we call the compendium, but Luis will talk about that in a minute. I just wanted to point out one thing. It is really, really difficult making sea basin scale maps of all sorts of different things. This is a hotspot of tension map we made specifically for GNSBI, where we show where the harbour porpoise distribution is, where the seabird migration routes are, and where the shipping lanes are. This map took a few months to make, and it's publicly available data. And we still cannot show the areas where the tensions, where countries come together and where the real tensions are. And this is what makes it very difficult to share what's happening in the North Sea between countries. But we have a solution for this. On the right, you can see our virtual climate lab. This is our sort of stakeholder engagement tool. We beam maps onto this just temporarily, and then they're gone again. And we found that this is a really good way of getting countries to share their data and also engage with different communities. So we can do this, for example, with fishing community. But it's the only one. Sometimes this is the only way we can show our maps and data. And then we have our viewer. And I'll hand over to Luis.
Sorry, I will go back a couple of slides. So these are a few screenshots of the web platform that I will present. And the web platform is developed within the framework of the NSBP project and the GNSBI. The NSBP is more like a technical implementation when we accommodate the data that is included from there, but we are not only limited or excluding those. We can present data information from all different kind of sources. And talking about data, we do have the 3 levels of information present in the platforms. In this platform is targeted for policy makers, experts, and general public. So we don't want to let behind the data. So the raw and processed the information. So when we derive maps or information and knowledge. So actual what we get out of that. This is made, so just a bit of a technical diagram. Disclaimer, this is an simple draft version. It is so simple and so draft that at the moment is controlled by some CSV files. In the future, we migrate to some databases, and it is built on this framework which is called Quarto, which just enables this in between dashboard and web application interactivity to build HTML pages that we put all sorts of context and content and interactivity. And that allows us to really go on the go and keep updating the content and the pages categories as content is produced. Since the content, of course, it comes from different sources. So we have EMODNet, I think, HostPar from ourselves, GNSBI. GNSBI, sometimes the data is a bit sensitive now, so we need to take care of what we publish since it's the source of truth for many things. But at the moment, I can already show you how it looks like. So, starting page. So let's say I'm a policy maker after reading the information, and I will show you a few examples. So here, in this case, so just to give an introduction of boundaries and wind farms, I put here an interactive web map that we have control over of the GNSBI, the NSEC boundaries, and the wind offshore planning. They want to see the layers that are present. So I see that are these ones. I can click on them to see information over it. Switch the language. No. Another task that we've been within one of the tracks of GNSBI is the multi-use. So this early exercise was on getting to see the different uses of multi-use sites within the North Sea. So and then we have this nice visualization that it can tell you the different categories of these multi-use sites. I keep going with the fisheries. We actually have also some preliminary results of the catch weight of species for a few countries here. And although this data is still not published as a layer, we can even go down and show some EMONet data so related to it until it comes final. To finish it off, just another example to link with the next presentation. We do have some information about shipping that it uses these navigate layers by John that are taking the vessel density routes with the GNSBI and then linking to what is the risk of collision of vessels in this offshore wind farms. Some information that was shot.
Yeah, and I think the final thing is that some of these maps that Luis has just shown, they're not available anywhere else. So they're products that have come out of the GNSBI partnership. And I think what makes them unique is that they are products that cover the whole of the sea basin. So the risk assessment tool here for ship collision is an open source tool. It's probably not hugely accurate, but as far as I know, it's the only one that for the whole of the sea basin can calculate a collision risk using this European data. So we're trying to make the move away from just 9 countries doing it by themselves to try and do this for the whole of the sea basin. And in the Baltic, they're already doing this. So the Baltic is working collaboratively with all sectors. For the North Sea, we haven't got to that stage yet. And that's what we're here trying to do, supporting with these tools. So some of these maps look very simple and like, half the data's missing. But that's because half the data's missing. That's just the fact of what it is. So it's really difficult getting sea basin-wide data. And data across the borders is not comparable, which is also hindering us. The harmonization and standardization for many of the data products is not there yet. But all of the countries want to do things in the North Sea. So we have to start speeding that up and getting this data and these sea basin-wide maps. Thanks.
Luis, Sharon, thank you. For 1 or 2 questions.
So I only want to understand. So you take this, you fill in this initiative. This is the Netherlands. To what extent is it being shared and being taken over? So I don't get it from the.
We're doing it for all of the.
Right.
So all 9 countries and the European Commission. So we're in this together. So
so each country has then a delegation or an organization.
Exactly.
Collaborate.
Yeah, and we have 6 different working groups. So I'm leading the data and knowledge sharing one, and I'm interacting with all of the delegates from all of the countries. So we're doing this for all of the.
Yeah.
I think there are answers in this. their answer.
Yeah, thank you. Yeah.
Peter.
Yeah, small question. Maybe you told it, I'm not sure. Do you, since it's quite sensitive, this data product outcome, do you publish the whole pipeline, how what you use as input, how you process it? Is that all available behind?
Yeah. So if you click on the map, you get the whole data source, everything, all the metadata, and where it comes from is you can find it with a click on there. The interactive table. We also have a big sort of screen behind us where we have exactly where all of the data comes from, because we think it's really important that doesn't matter who you are, you have to be able to find the source of the data.
But also for a heat map, you probably did some processing on it to extract information. Because the one we always print is.
I don't know if you saw the map. So if you can quickly go back to that.
Make it small, please. Otherwise,
The map, for example, in the one that I showed. So just here, so this is like here, we can actually see the information and the metadata until we put.
Yes, that one I understand. But if you do processing of based on several, you want to know also where it comes from. Why is the heat?
So the texture map I showed,
Yeah.
the bottom right hand corner has a huge long link which takes you straight to the
there isn't Peter.
No.
The last one.
If I may. I'm part of an international working group, which is under the UN and under the International Hydrographic Organization on marine geospatial information. And there we also dealing with standardization. So I would love to be in contact to deal with getting this together on the sea basin level.
That's
I suggest you take lunch and then you can. Okay.
Yeah.
Sharon, Louis, thank you very much.
Yeah, I'm between lunch and.
Okay, it's always difficult.
I had some influence, but I. So I will also try to keep it short, because and I think it's already like a benefit that we need, because I hear you say, well, there's no tool you are determining ship collisions.
probably wrong.
There is. So we have one, but I think that the difficulty is that each country has its own and calculating risk. But now I'm already in a kind of discussion. You can have multi ways of doing that. So each country likes to use their own tool.
Yeah.
So there's also no demand to do this for the whole North Sea. So we need to talk, and then we can. So I will keep it short, because I have a lot of slides prepared, but I don't have like a large platform to show. My name is Yvonne Koldenhof, by the way. I forgot to introduce myself. I work. So, and I work here at Marin. What we do, we can also share during lunch, but I work mainly on ship traffic intensities and ship risks and safety studies and safety assessments. So that's my role. So we use a lot of data, but we use it to get answers to questions that are asked related to the safety of shipping in my case. So I just want to briefly, because you're here at Marin, so I'm allowed to take you on the ship a little bit, at least to show the shipping perspective, because I don't have a nice platform to show, and I'm not collecting all the data. We are just analyzing a lot of data concerning ships. So I'm just going to take you a little bit on a trip down with shipping. So, I can skip this because it's the remark that the North Sea becomes a puzzle. And when you Google it, I always Google can I find a nice picture? Well, then I found this picture that the North Sea is the kleinste puzzel ter wereld. So it's the smallest puzzle of the world, but it's actually the most complex. Maybe that's the conclusion. And shipping is one of the pieces, because usually I start with, well, nature was there first, and then ships came on the North Sea, and then platforms, offshore wind, cable, pipeline, blah, blah, blah. There are a lot of other things came, but shipping is one of the first ones. Just a brief, just to also keep you awake a little bit. Do you have any idea how many vessels there are actually sailing on the North Sea? So here you see, this is well, everybody recognizes. You can see the main shipping lanes. So, and what we, for example, get from the data is just counting the number of vessels passing. And we heard some, I think somebody mentioned, well, pictures say more than a whole document when you send something to the Kamer or whatever. I also find out that these pictures, they sometimes say everything. We can make the most advanced data analysis, but just explaining that there are vessels, how many there are, and that they need space, sometimes already enough. But do you have an idea? How many? For example, these are the three main routes passing per day.
Per day.
Per day, for example, per sailing direction. Okay, you need almost 80 vessels per day going up and 80 vessels going down. And whether that's busy, well, that's also up to you. But normally it's stated that the North Sea is one of the busiest vessel shipping. And these are only like merchant vessels. So it's not including work vessels, fishing vessels, recreational vessels. It's only just a merchant. So it's tankers, bulkers, container vessels. So, well, if it's a lot or not, I leave it up to you. Maybe it's a nice discussion for the world also. But, so, and normally you see those static pictures. Everybody has seen the density pictures. But my message, I think, for today is it's not static. What you can see here is the density per month over the past 5 years. So it's a little bit shaped, but you see that sometimes it's red, sometimes it's not red, it's popping up, it's areas are changing. Well, you can see the development of the wind farm. So it's not one picture. It's not, we gather all the data for 1 year, put it in a map, and that's it. So this is just to show you that. And this is another one. So then I have my two main points already making. So it's not a static picture, and vessels need more space than just indicated. Well, okay, we write we just draw some lines, and this is the road for the vessels. Vessels have to deal with environmental conditions. And when they have an engine failure or their engine breaks down, they're not stopped. So it's different on land than compared to sea, or the other way around, actually. So what you can see here, I will start the movie, but normally when you start a movie, people don't listen anymore. So I'm first going to introduce what you'll see. So this is one day, the 5th of October last year, with well, high winds. So it was a very complex or challenging situation for the vessels at that point. And you can see the vessels moving. The different colors are different ship types, but that's not important. And normally vessels, if you have a normal day, they just follow the main root structures. But here you can see that during some conditions, they need actually more space than you just draw them. And by the end of the movie, it's becoming Monday morning, and then see if somebody sees what happens. So you can see here already, like vessels doing this. That's not like normal behavior, but it's something you do to make sure that your vessel is correct during full wind and waves. So this is the dynamic picture. It's a little bit, yeah, and it feels like. And they're coming. It's like firework coming from. Wow. You know what that was?
Aries.
Yeah, it's fishing vessels leaving. Yeah, so it's also saying that it's not fixed in time. So at certain moments, it's just learning a little. So it's not only dynamic in where they are, but to make it even more complex, also the industry itself is changed. So, well, I can talk for hours about this, but you can see that this is the normal vessels. Vessels tend to become bigger. You have autonomous vessels. You have vessels with sails again, so wind assisted. First, we get more control from offshore, and we're going to develop. So if you only look at shipping and Noordzee, it's already complex. And I think you not only have to look into, okay, what are the activities we are seeing now, but also what's coming toward us, and how does some of the pieces of the puzzle change in itself also. So that makes it our job even more nice, maybe, but also more. So it's not only the developments, but also within certain pieces of the puzzle things change. So we can learn a lot from data analysis, and I think I'm just going to take you, and I think then we'll slowly talk you to lunch. I just want to mention that there also can be other things besides infrastructural things that influence the patterns that you see. For example, now a couple of years ago, maybe some of you know it, a large container vessel sailing north of the Wadden Islands lost over 340 of their her containers. There was a large investigation done on how is it possible, why is it, what was the cause. We also did a lot of studies here, so you can also see some of the work we are doing here. And so we took the model in the basin, we did some simulations, and you can also see here, I always find it a nice movie, that it sounds easy, but if you see the movements really, everything. But as a result of this, also from the studies that's been done, the Coast Guard now given like an active advice during certain wind and weather conditions, saying, okay, we advise you to take not the southern route, but the more northern. But that's only during bad weather conditions. At least then they give the advice. But what we see is that after that, we see more vessels taking the other route, even though it's not bad weather conditions. So I'm just going to talk you through some slides, but this is where you get information from the data. Here you can see the tracks from container vessels over 200 meters. And this is what I meant with the southern route, and there you have the more northern route. It takes you extra miles. This is the picture on one hand of tracks in 2019, 21. You can already see it getting darker here, and it's even getting more dark. And if you end up in 25, and we also see it from other data sets, we see a kind of shift from vessels taking this route to this route. So also taking into account maybe regularity changes or advices can impact your, it's not only infrastructural things that. Okay. I also have some results with what we already see in the changing of routes as a result of the infrastructure, but I'm just wanted to make you a little bit aware that it's can be a complicated puzzle. But we can learn a lot from these data, and you can also see where the hotspots are. So because these are again tracks, and these are the newest, or I'm not sure whether it's the actual newest, but there's also wind farms, so you can see the effects. And you can, again, this is again the impact of introducing the wind farms. So this is 2019. And then you can see over time that the tracks, and now the wind farm is built. So you can see also a lot of activities in the wind farms. So it's not only the final result. So this is shipping now. We introduce wind farms. This is what it will look like. But in the meantime, there's a lot of changes in things, and that affects the safety. Again, then the message is that they need space. This is a picture. You all know the incident of the Julietta Day, where a ship starts drifting, and then everything's focused on that incident. But if you can see, this is the tracks of the vessels, of the other vessels in that same area. So if you introduce a wind farm there, you need to be aware of that it's more than, it's not solved if you draw lines and say, okay, this is for shipping, this is for shipping, that's not, then it's not solved. So the last, I think, I skipped one. This is the connection, so we need to talk, because we have a model, I think that's there since 19 ish. So it's a long time, and then we calculate. But again, we do this for our part of the Noordzee, because that's the question we get from. And this is also, the model has been developed, and it's now redesigned, and it will be like open source. So there's possibilities to introduce it. I hope, yeah, it's a very brief, it's not a fancy platform. It's just to take you a little bit on that, not only focus on the data itself. So that's the main message for me. Shipping is also a complex puzzle, and I think I have a lot of colleagues who can know a lot about this industry, and we have the connections also. It's not a static picture. It's usually presented as, okay, here we introduce a clear way and everything's fixed, but it's a dynamic part. So in my view, if you use information from the past, you get insights in the future. And I think it's also important, and I think you mentioned it also during workshops and stuff, it's not only focusing at the data alone. I've learned a lot by just talking to everybody who's actually sailing there. And so you get anecdotes, you get more information, you get more details on what the data actually say. So that's maybe strange message for a data science, a data platform, but not only focus. Don't do this. You have to interpret the data correctly. You need to talk to experts. And finally, this was more our last remark. I think we showed that as the 3 institutes, we have pieces of the puzzle. We have a lot of information. But I think we need to collaborate with the industry and maybe authorities to make it into a complete picture. But that's why these days are here, and we need to talk. So that's what I wanted to say in short. So I think we are all up for lunch. And maybe
they're not allowed to lunch yet. No, because
that's
make room for one question.
Okay. Well,
no one dares to.
What kind of increase is expected when the northern route is opened, and when is that? Is it somewhere in your mind to?
It is in one of the scenarios. So we are also looking into more story-like, scenarios 2050 and beyond. And then is the intensity of shipping that really take the northern route is one of them. But when it's actually there, and so it's a little bit a crystal ball, but it's at least something that we know.
It's with the energy planning. It's also until 2050. Is this so?
Yeah, that's true. But we try to take it into account, but it's difficult because there's a lot of uncertainties about it. Yeah, and yeah, and maybe it's good because afterwards we can go to lunch. It's again downstairs. I'm not sure when the workshops will start, but there's
I
also,
think 10 minutes later as programmed, but we'll manage that.
but I would just want to mention that there's also a possibility to join kind of tour. We are not allowed to see the major basins because there's work being done that's probably for defense. So then it's closed. Isn't it anymore? We can go if we want to the zero emission lab, but we can go to the simulation center and they put on something to show. So I think this is also the nice thing. So during lunch, there's also room for, so if you want, then just catch me and we will organize it.
Ja, heel kort even voordat we naar de lunch gaan. We hebben dus een parallel programma zometeen tijdens de lunch. Dus op de rondleiding, maar we hebben ook tegelijkertijd pitches. Het gaat in het heel kort over een operationeel vraagstuk van de Rijkswaterstaat. Te maken met scheepvaart en de golven. Meer kun je daar zo meteen over te weten komen. En we hebben de markt gevraagd om daar met ons over mee te denken, om oplossingen te denken. En die worden zo meteen gepitcht. Dat gaat ook vrij technisch. En er zijn ruimte voor vragen hier en daar, maar er zijn ook veel